The first few chapters of this book are a review of DC and AC. So what I'm going to do is illustrate some of the problems, and then you do them again, and then save them until next time we see each other. No matter how simple a problem seems, always do a schematic diagram and then show all your formulas. In other words, show all your work. In this case, we're looking for total current. In this case, it's V over R, 100 volts divided by 5 ohms for 20 amps. In this problem, we're looking for the resistance of a lamp, and we know the volts and the current. So we simply solve for resistance. V over I, that's 12 volts divided by zero point 0.5 amps, 24 ohms. And by the way, when dealing with lamps, it's always important to measure the current and then calculate the resistance because the resistance will change depending on the temperature. Here is a problem with two resistors. So the first step is to find the equivalent resistance by saying it's 35 ohms plus 65 ohms, which equals 100 ohms. Next, redraw the circuit so that you can find the total current. So now we have 120 volts and 100 ohms of resistance. So the current is 120 volts divided by 100 ohms, 1.2 amps. Using the total current, then go back to the original drawing, and then you can find the voltage drop across each resistor. In this case, for the first resistor, it's 1.2 amps times 35 ohms and equals 42 volts. For the second resistor, it's 1.2 amps times 65 ohms and a total of 78 volts. For two resistors in parallel, use the formula shown, which says that the equivalent resistance is R1 times R2 divided by R1 plus R2, which equals 30 ohms times 30 ohms divided by 30 ohms plus 30 ohms, which equals 15 ohms. And this is a good formula to memorize because it can be used for capacitors and inductors. When dealing with more resistors in parallel, then you have to use the general formula. As you can see, it's 1 divided by resistance equivalent, and that equals 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. Once you insert the numbers into the formula, eventually you come to the place where 1 divided by resistance equivalent is equal to 0.08 ohms. Then you take the reciprocal of both sides and you come out that the total resistance equivalent is 12.5 ohms. As always, redraw the circuit so that you can do more calculations. So now we have 125 volts and then we have 12.5 ohms of resistance. Now it's easy to calculate the total current, which is 125 volts divided by 12.5 ohms, 10 amps. And then we can calculate power, which is V times I total. In other words, 125 volts times 10 amps, 1,250 watts. By the way, true power is measured in watts and can only exist in pure resistance or in the case of rotations, as in a motor. For other types of power we will see later on are expressed in different terms. Once again, make sure to read the chapter and do the problems and hang on to them until next time I see you. The book contains many, many pieces of information, but I'm only concentrating on the homework problems.